Perfect, thank you. So let's see where you are from. I hope you can see my screen now. So we have 4 attendees coming from the 5 aerospace and aviation technology sector. 6, okay, that's quite normal for our webinar that most of the people are from the aviation. I'm always curious where the others are from. So in case the 3 other people would like to share it in the chat, please feel free. And yeah, thank you very much for that. So aviation sector, good to know for us. It's always on the first spot for us. So yeah, before handing over to Niklas, who is in London, and then to Toralp, who is in Hamburg, and then to complete the Europe field, we are going to Erik in Toulouse. So thank you for joining, Erik from France today. And Niklas, may I ask you to introduce SAI and Toralp to the attendees?
Yes, sure. Welcome everybody also from my side. My name is Niklas. I'm the Vice President of SAI. And I'd just like to give those of you who are joining for the first time maybe a quick overview of what we are actually doing. We are an association that is relatively young, both in terms of the time we were founded and also concerning the members who we have in our rows. And we basically have 3 main goals that we pursue. We want to increase the awareness of sustainability in aviation by means of educational events like this one today and many other formats as well. We want to foster science in the field of sustainable aviation and promote this with the diverse backgrounds and knowledge we have in our association. And then also we want to certify sustainability throughout academia, the industry, and all other sectors to show everyone where real sustainability and sustainability initiatives within the aviation sector lie. And despite having a lot of people attending from the aviation and aerospace sectors today, in our ranks, we actually have a lot of non-aerospace people, interestingly, and we try to get as many views as possible from different backgrounds, people with different experiences into our work, because we feel that this really helps the cause of sustainable aviation. Yes, Toralp will introduce himself also in his presentation later on, and we are also very excited, obviously, to have a guest today from the Green Pilots, Erik Borrat. Lisa, you already mentioned it. And he will also present his association later on a little bit, but he's the EMEA account director for Open Airlines in Toulouse, and has a leading position thus in Open Airlines and also their Green Pilots Initiative. He has a flight engineering background from the École Nationale d'Aviation Civile, and he has been involved with his organization in the development of solutions like SkyBreathe at Open Airlines that leverages machine learning and data analytics to increase the operational efficiency in the field of aviation and at airlines. Yeah, and Toralp has been a member with us for quite some time now. And he is also active in this group organizing events and webinars. He has a pilot background and is actively pursuing that. That's why today's topics are definitely at the heart of what he's doing as well. So I think we're going to see a nice and interesting combination of presentations today. Right, and from that point, I think I can directly hand over to Erik, right?
Okay, thank you very much, Nicholas, for this introduction. I'm very happy to be invited to such a webinar to discuss about important topics such as sustainable aviation. And I really thank Sustainable Aviation Initiative to welcome us to this joint webinar. So what I suggest is that we can start with the first presentation, and I'll share my screen. You tell me if that's okay for you. Okay, so yeah, before I start, a brief introduction Green Pilot, but also Open Airlines, because Open Airlines is the initiator of this Green Pilot movement, which we launched this year, and we are very happy to welcome all the aviation lovers, pilot, but not only pilots, to join this movement to contribute to a more sustainable aviation. And this is the topic of today's webinar: how digital technology and pilot engagement can make aviation more sustainable. As Niklas presented me, my name is Erik Borrat, and I've been working at Open Airlines for many years now. I'm a fuel expert within the company, but also I'm working as a EMEA director to work with airlines and trying to help them reduce their environmental footprint thanks to digital technology, but I'll come back to that. Okay, so Open Airlines, just a few words. We are digital leader in fuel efficiency, and Open Airlines is the company initiator of Green Pilot, the Green Pilot movement. We are an innovative software provider for airlines, and our raison d'etre, or our mission, is really to accelerate the world transition to sustainable aviation through digital technology. So as we are seeing some upturn in the traffic, even if the situation remains a bit weak in some areas of the world, I would like to have a brief overview of the industry challenges that were existing before the COVID-19 crisis, but also that became even more accurate due to this unprecedented crisis. So aviation is under social pressure. Since 2018, there is this anti-aircraft movement or aviation bashing movement led by the young and influential Greta Thunberg, which has been really developing across Europe, but not only, also in America. And in Sweden, for instance, before the COVID, this boycott would have caused a drop in traffic in 1 year, according to the Swedish Transport Agency. So really aviation is under social pressure, but it's also under environmental pressure. Aviation represents around 3% of worldwide CO2 emissions, and air transport accounts for 12% of transport-related emissions. But the real challenge of air transport is its growth, which is around 4 to 5% per year. And given the growth in air traffic, if nothing is done, really aviation's carbon footprint is expected to triple or even be multiplied by 4 by 2050. And this is why there is this huge environmental pressure. Finally, aviation is also under economic pressure. Well, the economic crisis that we are living today is one of the strongest the world has ever experienced. It's a very difficult time for all of us, especially in the airline industry. The whole industry struggles, and the competition will be very tough. But hopefully we can see a strong commitment from people, from their expectation to be able to travel again and open their eyes to the world. So this is really a hope for aviation. And as Ed Bastian, the CEO of Delta Airlines, recently said, travelers should not have to choose between seeing the world and saving the world. And this is exactly what we want to do through this Green Pilot movement, is showing the world that aviation can be sustainable, and the pilots are real actors in this sustainability of aviation. So from your perspective, what's the airline's first cost? And I'm sure everyone here knows it. It's fuel. Fuel is, of course, the most important concern because it represents the #1 cost for an airline. Usually it's around 30% of the operational cost, and sometimes can be even more. And today, jet fuel price is again rising rapidly following the crisis, reaching now almost $80 per barrel in average in the world. So any airline that is willing to get a profitable recovery following this crisis and want to be more competitive, preserve its cash while reaching environmental excellence, and this is the topic of today, they should tackle the issue of fuel. Well, becoming a forward-looking airline, what it means, it's addressing the fuel topics and how to do that. We are talking about fuel efficiency, which is today a real tool and a real power for airlines to reduce their environmental footprint. And this is what we are trying to see today, how airlines, through the pilots and through the digital technology, they can achieve this sustainable way of operating the aircraft. So we have just seen before that if no action is taken, aviation CO2 emissions are expected to grow by plus 45% in the next 15 years. But as I said, hopefully there are solutions that already exist today to act on this important topic, climate change and CO2 emissions. So there is no need to wait for the hydrogen electrical aircraft. There are already opportunities to reduce fuel burn and of course, consequently reduce CO2 emissions by, for instance, by optimizing the current fleet operations and how, thanks to big data, artificial intelligence, and machine learning technologies. And this can be achieved without compromising any of the airline's operation, and it's available today. There is no need to wait for new technology or new type of aircraft, such as the hydrogen or electrical one. Well, probably know Benjamin Smith. He's the CEO of Air France KLM Group. And he says that the COVID-19 crisis is forcing the airline industry to reinvent itself. First, only those businesses that can transform themselves quickly, deeply, sustainably, they will survive. And at the Green Pilot, we are really convinced that airlines need to take this opportunity raised by today's challenge to bounce back after this COVID-19 crisis. And well, the better way to do it is trying to fly greener. So how to fly greener? Well, leveraging big data analytics and the pilot engagement is really a winning strategy and a game changer for airlines to contribute to this more sustainable aviation. But first, let me show you what I mean by better analytics. Well, one of the main challenges of digital technology, digital transformation, is really to explore the data and turn it into relevant information. Well, when we talk about digital, it's not an end in itself. It's really something that will enable a whole new level of understanding of the way the airline is operating, the way the aircraft is burning fuel, etc. So one of the biggest barriers to implementing such effective fuel efficiency program, we've talked about that. Fuel efficiency is really the tool that can be used today with digital technology to reduce the airline environmental footprint. And the biggest barrier to implement it effectively, according to a recent study done by Aircraft IT, is really the issue of extracting, processing reliable data. And according to this study, 40% of the surveyed people are taking management decisions based on what they themselves call as unreliable data. So that's the first high challenge, is really to get this reliable data. And I'm sure we've all been there, like our manager is asking for reports on food-related topic. This request is more than reasonable. We know the data exists somewhere, but we don't know where exactly. So this is the first barrier. The second one, and although it is important, data gathering and cleansing is very low value activity. And from my experience, I can tell you that it can be very time consuming. So in short, being able to gather and process data is really half the battle. And you probably know this famous quote from Lord Kelvin, you cannot improve what you cannot measure. And when we talk about digital technology, the ultimate goal is really to transform the torrent of raw data that is captured from individual flights, transform it into actionable insight to optimize the airline's operations. Let me share with you the three main phases of such a process to be very successful. The first thing for airlines to be able to really benefit from digital technology is, first of all, to automate the integration of all the data that are there. And when I talk about data, I'm referring to the data coming from the aircraft, the flight data recorders, the black boxes, but also data coming from the operational flight plans that is prepared by the dispatchers, or data coming from ACARS messages that are there to send reports on the fuel burn, the fuel consumption during the flight. But there are also other types of data, the weather, the load sheet for the weight and balance of the aircraft, etc. All these data are somewhere, and the real goal here is to have it in the single repository, have it processed automatically. And this is the first step of digitalization for airlines. The key word, to understand it, is automated. Because a handmade, do-it-yourself approach is really risky and is riddled with potential pitfalls, including human errors, and that represents time and financial costs for an airline that they can't afford. So that's the first part, having the data collection very automated. Then the second phase of this process is really that the data have to be analyzed using efficient, relevant algorithms. In our case, considering the amount of data that is gathered from the black boxes of the aircraft, from all the flights that are operated by each airline, we think that machine learning, artificial intelligence, and big data algorithms are the most efficient to analyze all the airlines operations and treat all the airlines flights. But finally, what is important in this process is the communication, because the airlines want to visualize these results in various ways. They can visualize it through interactive reports, graphs, dashboards, KPIs that they share with management, with other airlines. But more importantly, it must be easy to access by all the stakeholders of the airline, to facilitate, to improve the communication, and then to help to take the decision-making decision. So that's the three main steps of successful fuel efficiency program. For the first time ever, with this kind of solution, the airline can look at what they plan to do and what actually happened. And that is key to improve their operations. So if we put it in a nutshell, leveraging big data will bring, first, a better understanding of the airline's operations, then, and what's the goal, a reduction of the fuel cost and the CO2 emissions, so the overall environmental footprint. And at the end, it increases their margin, offers a great competitive advantage while reaching environmental excellence. And this is why it's so important for airlines to target this kind of program, because while they will preserve their cash, increase their margin, they will also reduce their environmental impact. So now that you have all the needed analysis in your hands, you understand what I mean by better analytics. Now let's talk about the communication and focus on the pilot engagement, as we all know that the pilots play the key role in fuel efficiency, but also in the overall airline's operations. So let's focus on the pilot engagement. You probably know that change management can be very complex, and it's really hard to distribute efficiently all the information regarding fuel saving procedures, regarding all the SOPs that an airline can, standard operating procedures that an airline can ask the pilot to operate the aircraft. And it's even more difficult with pilots that are always on the go. Probably Toralp knows something about that. So really a successful fuel efficiency program can be effective only when all the related staff work together and are fully engaged, pilots included. So really what I would like to highlight here is really the fact that the pilots are key players, but if all the staff are not working together to support this green culture within the company, that won't be efficient. So the key thing to have a successful fuel efficiency program is really to set up an efficient fuel team. So when an organization undertakes projects or initiatives to improve their performance, it often requires change. So when you set up a fuel team, the first thing to consider is that there are many stakeholders when it comes to fuel management. This is probably the main reason why we advise airlines to gather a multidisciplinary team who can analyze the big picture and strategically address it. So if you see here, all the people involved in this fuel team are not only pilots, but dispatch, the management with finance as well, the engineering, the maintenance of the aircraft, all these departments must work together effectively with the fuel team. So an efficient loop between all the team is vital to succeed. So the fuel team is a key player, but you understand that all stakeholders must spread the fuel culture through all departments. They must play their part of the task to try to influence as much as they can and contribute to a more sustainable operations for the airlines. So to discuss a little bit about the software Open Airline is providing, so Skybreeze Fuel Efficiency, it offers tools to communicate effectively with all stakeholders within the airline, and this communication can be really tailored to various needs. For example, I can give you the example for a CEO. A CEO will be able to steer the company by seeing all the overall savings and contribution on the fuel burn reduction. The head of flight ops will be able to see how the fuel initiatives are implemented within the company and are providing progress in terms of CO2 emission reduction. And another example would be the pilot. The pilot will be able to see from this kind of solution what is his or her performance and how we can compare that with his or her peers. This will help to encourage everyone within the company, pilots included, trying to fly greener and trying to achieve better results. So to engage pilots, what we do is we equip all the pilots with a mobile application that acts as a virtual coach to help them providing briefing, providing debriefing, recommendations, advices on how to fly greener. And this is this mobile application called MyFuelCoach. So MyFuelCoach provides recommendation on fuel best practice to the pilot. but also on many other KPIs about the flight operations. These numerous recommendations can take place before the flight to prepare and anticipate all the potential actions that the pilot can undertake during the flight, but also after the flight to show how well the pilot performed and what are the results he achieved, but also how he could have done better to save more fuel and reduce even more its environmental footprint. So what we are convinced about is at Open Airlines, and Green Pilot is there because of that, is that pilot engagement means better results. So I would like to share with you some evidence of why I'm saying that with pilots engagement, you can achieve better results. So let's start with this example from an airline, Cebu Pacific, which is a company operating in the Philippines. So I told you that Skybreeze help airlines improving their fuel efficiency, but it is doing that in all business areas. Flight operations, for sure, but also the dispatch with the preparation of the flight, the maintenance with the maintenance of all the engines, which allows to have a higher engine performance, but also ground operations or even commercial operations. And probably since day one, what we have paid special attention to is the pilots, because the pilots are the ones that fly the aircraft, and obviously they do have a lot of impact on the fuel efficiency of the airline. So we've worked with a lot of pilots since the beginning of this project. Now we understand them, we've got their trust, we have very positive feedback from them, and this is giving incredible results. And today I'm sharing the example of Cebu Pacific, the low-cost carrier in the Philippines, to show you how this pilot engagement has made spectacular progress in fuel preservation and CO2 emission reduction. So the three curves we can see here, they show that in just a few months after the introduction of the MyFuelCoach mobile app to the pilots from Cebu Pacific, they show how the briefing and the debriefing module from this app allow to improve dramatically the compliance of the application of the best practices or the green initiatives that the pilots can do during the flight. So these eco-flying techniques, we can take the example of single engine taxi. So the principle is to shut down one engine during taxi in, which will reduce the fuel burn and therefore reduce the CO2 emissions. So we can see that at Cebu Pacific, before they had this kind of digital technology, there was almost no application of such initiative. And in a very few months, they end up with much more than 60% compliance in overall within the airline. It's the same if we talk about the second one, which is the use of the reverse during landing in idle mode. So you can either use the reverse in in high thrust, or you can use an idle thrust to reduce the fuel burn, to reduce the CO2 emission, of course, when the safety allows it. So at Cebu Pacific, they were plateauing at 25% application rate, and when they saw the potential and all the savings that could be achieved by the company, they improved this compliance and end up with more than 70% application rate in overall. And the last one is probably an initiative that was already known by Cebu Pacific pilots, which is the reduced acceleration altitude. So it is the principle is to accelerate at a lower altitude to reduce the drag, to reduce the thrust, and therefore reduce the consumption. This initiative was already known and shared among the pilots community, but still, with the help of a digital tool, with the help of a dedicated coach, they managed to improve their compliance by even plus 20%, which at the end of the 3 years, or even in less than 3 years, allowed Cebu Pacific to save 50,000 tons of CO2 emissions with only these three initiatives. So what we understood from Cebu Pacific case study is that the fact that Frances Torres, the director of flight ops of this airline, said that with this kind of digital technology, pilots are much more aware of their fuel performance and how they can improve, because now they feel engaged in the process. And this is the key word, the engagement of the pilot. This is how we can see that it allows to achieve better results. But let me show you a second example of another airline, which is not a different airline, not a low-cost carrier, but a flag carrier in Ukraine, which is Ukraine International Airlines. They operate a fleet of 35 aircraft, mostly Boeing 737, but also Embraers or wide-body aircraft, such as Boeing 767 or Boeing 777. So Ukraine International Airlines had a very fuel-conscious culture. It means that they had put many fuel-saving best practices in place to reduce their fuel burn and their environmental footprint. For example, they had implemented the single-engine taxi-in initiative, but they were plateauing at 25% application rate. And once they introduced the MyFuelCoach mobile application to their pilots, this is when they made a difference. In just 4 months, they went from 25% application rate to more than 75% application rate, which is quite significant. And you can see that they were plateauing for many months. And once they got the right information in their hands, they managed to improve. And this is exactly why it is key to involve your pilots, because it means that if you give them the right tool, the right information at the right time, you can expect to get higher fuel savings and therefore reduce further the aviation's CO2 emissions. So like Cebu Pacific and Ukraine International Airlines, there are many other airlines all around the world that have decided to implement a fuel efficiency program, and I wanted to boost it by implementing our solution, Skybreeze Fuel Efficiency, because it's based on digital technologies such as big data algorithms, machine learning, and artificial intelligence. So this is how these kind of technologies will contribute for the whole aviation industry to reduction of the CO2 emissions and to make it more sustainable for the whole for all the airlines. And as you can see from this chart, there are airlines coming from all over the world, North America, South America, like Aerolíneas Argentinas. From Europe, there are many airlines, Air France, TAP Portugal, Icelandair, or others like Air Greenland, but also airlines coming from Africa, Middle East, India, Asia, Pacific regions. All the world is focused on reducing the CO2 emissions, and by implementing such a fuel efficiency program, they achieve a significant result. I'll share with you in my last slide some real numbers. But as I said, Open Airlines, we want to accelerate this transition to more sustainable aviation, and we wanted to go further. And this is exactly the reason why at the beginning of this year, we have launched the Green Pilot Movement to increase this pilot engagement, because we analyzed and we see with our partner airlines that it is key to go one step further. So through this initiative, the Green Pilot, we want to put people at the heart of this fight against climate change. And we want to let the pilot speak out, lead the change, and show the way toward a more sustainable aviation. This is really pilot action that will help to do better, to have a better impact on the whole industry. And this idea of the Green Pilot actually was born during a conversation with Bertrand Piccard. So you probably know this guy. He's the famous guy the famous pilot who flew all around the world without burning any single drop of fuel, thanks to his aircraft, the Solar Impulse aircraft. And we discussed with this guy because he selected Skybreeze Fuel Efficiency, our solution, as part of the solution he promoted and labeled with the Solar Impulse efficient solutions. So when we created this Green Pilot movement, it was to bring the pilots all together because we know they can matter. And really we want to strengthen synergies between all the members to promote green actions, to make the air travel more efficient and greener, and make it as efficient as possible. The aim is also to raise awareness of the world aviation industry's efforts, all the efforts that are done for the environment, because people are not always aware of all the actions that are taken by airlines, by pilots, to go to a greener and a more sustainable way of flying. So we think that this information needs to be spread on a larger scale. And we know that if aviation is encouraged, acknowledged, and helped in this transition, in this transformation, it will help to develop existing initiatives and tap into new ideas. So this is why we had this discussion with Bertrand Piccard, because we wanted to raise this new Green Pilot movement. And now Bertrand Piccard and its foundation, the Solar Impulse Foundation, endorse the movement and are our official godfather. So we are very proud and happy to work with the most fuel efficient pilot in the world. The Green Pilot actually has two main missions, and I would like to share that with you. The first one is to encourage actions for aviation's transition, to promote these actions to the world. So our actions are carried out in three ways. The first action we take is we want to educate and promote the fuel efficiency best practices, fuel efficiency program that I talked about with the example of Cebu Pacific or Ukraine International Airlines through this Green Pilot community. But this community is not only pilots, it's also aviation lovers, airline workers, anyone who feel part of this or who loves aviation and are part of the care for the environment, they are welcome to join this community. So the second action we want to do is to organize a Green Pilot Trophy, which is, we hope will collectively bring better, much more fuel savings and bring down the whole air transport emissions. During this challenge, we want to have a higher impact on the CO2 emissions. The third action we will do, and we want to organize a Green Pilot conference. So this is an annual gathering of the movement, which will bring all the Green Pilots together and will last one day, during which we will display a very diverse program with inspirational talks, debates, and at the end there will be an award ceremony for the Green Pilot Challenge participants to reward all the action that have been taken by all the members of this movement. So of course, we encourage you to join the movement. You have the URL just in the slide, and we welcome you, and we'd be very glad to have you on board and to have your contribution for the aviation industry. If you're not convinced, and probably you will listen to Hugo Posamai, who is a captain on Boeing 777. So the reason why he did become a Green Pilot was that the fact that he felt concerned since his childhood for environment. He wanted to become a member because most pilots feel concerned because they always try to save fuel, they try to save time in their everyday jobs. And when Hugo heard about the Green Pilot, for him it was a no-brainer. He should join the movement because he felt part of the problem, the CO2 emissions. So he wanted to be part of the solution by flying greener. And I hope that it will have the same impact on other pilots' brains. So before ending this presentation, I just would like to share a few words again about Open Airlines. As I said, we are a digital leader in fuel efficiency. We try to help airlines to reduce their impact through digital technology. And in 2019, before the COVID-19 crisis, of course, we had an interesting growth which exceeded 40%. As Lisa said, we are based in Toulouse, in south of France, and we are at the heart of the European aeronautics industry, close to Airbus and all the other companies in the aeronautics industry. We also have some offices located in US and in Asia, where we provide local support to our airlines, where we do help our local customers there. And just to conclude with the actual numbers I promised, this is the contribution of Open Airlines in 2019. We are very proud to say that we help airlines reduce their fuel burn by 190 million of kilograms of fuel, which represent almost 600,000 tons of CO2 emissions, which is the equivalent to planting 75 million trees. So we are really proud to these numbers, but we think it's not enough. This is why we have this Green Pilot movement, and we do hope that next year some of you can join the program and be part of these numbers. So now that I've shared the presentation, I just want to give you the 4 takeaways from what we've seen today, just for you to remember the key messages on how digital technology and pilot engagement can contribute to a more sustainable aviation. So the first one is that the fact that data is key to better engage the pilots on the fuel saving achievements. And remember the quote from Lord Kelvin, you cannot improve what you cannot measure. So having the data is really key. The second one is communicating effectively with all the stakeholders within the airline and within the industry in general is necessary to better achieve fuel savings reduction. The third one, we've seen that with how empowering pilots with a dedicated tool means more results. We've seen the examples from Ukraine International Airlines, but also Cebu Pacific. And the last one I wanted you to remember, probably the most important one, is that we want to strengthen synergies between pilots through this Green Pilot movement. And we do think that it will help to further eliminate the CO2 emissions and make air travel greener. So thank you very much for listening to this first part of the webinar, and I will be very glad to answer all your questions.
Thank you very much, Erik. Really, really interesting. As I'm working for an airline as well in the sector of business aviation, that was really interesting for me. I have a lot of questions in my head, but we already have a lot of questions from the attendees, so we're gonna share that first.
So
maybe
I'll stop sharing my screen.
That would be perfect, yeah.
Okay,
so we
thank
can
you.
Share my screen and all the questions. So we already have 8 questions. In case anyone would like to just send in your questions on menti.com with the code you see here or in the chat. So first question, are you ready?
Yep.
Yep, good. Can you provide an example of using AI in examining data analysis?
Right, that's a first very good question. Yeah, there are many examples of how using artificial intelligence help examining data analysis. Let's take one. So probably what I would say is when you deal with big data and when we deal with all the flight data recorded from the black boxes of the aircraft, and when we deal with the airline they operate thousands of flights per year, you need to do it automatically. And some artificial intelligence that are key to process this data are, for instance, when you deal with this huge amount of data, you often have, and it's normal, erroneous numbers, missing parameters, the recorder that are not recording well. So how do you deal with erroneous data? Well, artificial intelligence help you to clean the data, help you to for instance, rectify your trajectory. Let's say that you do miss the coordinates of the aircraft, but you do have the speed of the aircraft, the heading of the aircraft. So with artificial intelligence, you are able to recompute the trajectory of the aircraft and be able to do monitoring and analysis on that. So this is an example on the cleansing of trajectories to retrieve the whole trajectory when you have erroneous or missing parameters. But of course, when we do look at fuel savings, when we compute all our fuel saving results, artificial intelligence is there to help calibrate models based on historical data, based on statistical data. It helps to calibrate and then to be able to compute real savings based on calibrated data. So there are many ways to use artificial intelligence, but for sure it's key when you deal with the big data volumes.
Okay, I think that was pretty clear. Let's see the next question. How can we ensure that AI data collection and analysis will meet cyber safety criteria?
So indeed, cyber safety is a real concern for airlines, and we are seeing today with the COVID crisis that many companies are hit by cyber attacks. To ensure the highest standards, you need to have the digital tools that comply with the highest standards in terms of cyber security and safety. So, for instance, at Airlines, we work with the highest standards in terms of security. We are labeled with the highest security standard. We try to have the most securing machines. So for instance, we are working in the cloud. We are working with data center providers where all the data are encrypted, stored at encrypted data. We use a very secure protocol like SFTP, SSH protocols, etc. So indeed, artificial intelligence is a good tool, but you have to comply with the highest standard in terms of cyber safety. Otherwise, there are risks to get attacked from a cyber attack. Yeah.
And as I understood you correctly, there are mobile apps for the pilots, right?
Yes, correct.
Okay. Yeah. Of course, there need to be
all the exchanges between the core of the software and and with the location where are stored the data, all these protocols are encrypted with strong encryption protocols. So there is no possibility to read data that are in transition from the place where they are stored to the web application or the mobile application for the pilots.
Okay, thank you. Are there not any risk related to the optimizing or reducing fuel loads so that planes end up without fuel mid-air? I think we all know the news saying, oh, we had to land somewhere else because there was no fuel.
Yeah, that's really a concern for airlines, and often a question asked or let's say a barrier raised. Actually, fuel efficiency will never goes against safety. That's the first thing to understand, is that fuel efficiency is here to make it more efficient, but not to make it more risky or to go against the safety principles. So, for instance, if a pilot needs to take extra fuel, he shall take extra fuel. What the fuel efficiency purpose is to reduce the quantity of fuel loaded in the tank when it's not needed. So for instance, if you have a very clear weather, you have not so many passengers on board, the flight planning system is very accurate, so you don't need, probably you don't need to take extra fuel. And this is where the software will provide recommendation on, hey, you have a very accurate flight plan, weather is okay, there is no risk of being on hold at arrival, so why should you take extra? Try to limit your extra fuel. And sometimes some pilots will do that, others will just take extra because it's an habit, or it's like they are used to take extra, so they take extra, but there is no reason behind. So now airlines are trying to assist and guide pilots on the fuel loading on board, and especially on the extra fuel. But it's not only about the pilots; it's also about the dispatchers that are preparing the flight. All the dispatchers shall be careful about not taking unnecessary fuel, but at the same time comply with the safety first, and have all the reserves that are necessary to operate the aircraft.
Yeah, and I think we all agree that safety is always priority.
Oh yeah, definitely. Safety will always be the first principle for air transport.
Exactly. Okay, next one. How do you ensure that non-cost sensitive parts of aviation, for example, business and general aviation, to use your solution if there are less incentives for them? So honestly, I don't know why somebody thinks that business aviation is not cost sensitive. I totally disagree to that. So I'm working in business aviation, but question to you.
Okay, yeah, well, sometimes I can understand why there is this question, because sometimes on business aviation, for instance, the concern is probably more of being on time, being providing the right service, but for sure that you are cost sensitive. I can understand that, but probably it's even more important to be on time than to fly with let's say a lower fuel burn. But I kind of disagree with the question in the sense that all the aviation industry, business or general aviation, will be highly beneficial if they reduce their fuel burn, if they reduce their environmental footprint, and our solution is there really to provide these kind of incentives. Environment is a big one, and about the cost sensitivity. When we look at the return on investment of such solution like Skybase fuel efficiency, we are talking about times 30 to times 50 what it costs. So really, it's a solution that is both interesting for sensitive or non-cost sensitive aircraft operators, but for sure it is key and important for the environment and reducing the overall CO2 emissions.
Yeah, and I think from my work-related background, I can say that there are more and more customers asking what we do to be more sustainable. So that's an incentive also as well, that the clients are just asking for it.
And even cargo companies, we have been discussing with many cargo airlines in the last few weeks, and they are all looking at reducing their CO2 emissions, tackling the environmental issue, because now it's really a question of what do you do to contribute to a more sustainable aviation, and many airlines and aircraft operators are really concerned about this new topic.
Yeah, totally agree. So next one, do you coordinate with ATC and other stakeholders to ensure the measures you propose are implementable? So continuous.
Yes, that's really part of that's really part of our daily work. This kind of the fuel efficiency solution is there to show what is possible to do, and we do take into account all the constraints from aviation, the weather, but also the air traffic control. There are many constraints to make all the to ensure the security of all the safety of all the flights, and ATC is a real stakeholder to be that need to be involved in the discussions. And exactly, a fuel efficiency program like that will give the airline and the ATC concrete analysis, concrete measures to show that whether something is implementable or not, or whether it is beneficial or not. We mentioned continuous descent, but continuous descent is really something that can be implemented at different flight levels, considering different ATC constraints, like between different airspace. So you can have continuous descent between different flight levels. That would be at least continuous descent. But for sure, the idea is to provide ATC with more information, more insight about what is at stake and how they can have a positive impact on the environment by allowing more continuous descent, by trying to make the airspace more efficient in terms of fuel consumption. So and we have seen examples with like Fly Dubai. They really discussed with ATC and managed to change a procedure at arrival at their hub. So it's something that have a very positive impact for everyone.
Yeah, I'm waiting for the topic of a single European sky here.
Also, yeah, big one.
Okay, next one. How is the app My Fuel Coach connected to data of the aircraft fuel consumption? Is it implemented into the EFB?
So My Fuel Coach is a pre and post-flight application. So it means that there is no direct connection in the cockpit through an EFB. However, it is an application that is a mobile application, so can be part of an EFB. The connection between the aircraft fuel consumption is the same than Skybreeze. It means that every day we integrate automatically all the information from the flight data recorders, from the flight planning system, and we do our computations, and then we, let's say, transfer it to the web application Skybreeze, and in the same way to the mobile application My Fuel Coach. But it totally works offline. You just need to upload the flight results first, and then it works offline. So it's a mobile application and does not need to be like an EFB application. What I would like to add is about the EFB application at Open Airlines, we are also working with other kind of solutions, digital technologies, which are EFB's application. It's called Skybreeze Onboard, and this is an onboard system that will provide assistance to the pilot to be more efficient in real time in the cockpit. And this particular application can be connected to the aircraft through AIG, or or you can download the data on the ground before jumping on the aircraft.
Okay, thank you. Do you have an estimate of what the maximum share of fuel carbon emissions savings would be if all of your proposed measures were applied on an average flight?
Well, when we look at the different initiatives that can be done on a given flight, in average, we are talking about a reduction of the fuel burn from 2 to 5%.
Mm-hmm. Can you maybe just let us know some examples of the?
Yeah, for instance, what I mentioned, the single engine taxi that would, or on a A320 or Boeing 737 could help to reduce from 10 to 30 kilos. Reduced acceleration altitude it's a bit it's like around 30 to 40 kilos on an incline for a Boeing 737. But if we are talking about bigger aircraft, of course, the quantities are much bigger. A continuous descent can allow to save from 20 to 50 kilograms for this kind of aircraft. There are other initiatives like the reduction of the extra fuel that will have an impact on the fuel on board, and therefore on the weight of the aircraft, and therefore taking into account the cost of freight, it will reduce the fuel burn. So there are many opportunities to reduce. And in overall, well, we are talking about from 2 to 5% fuel burn reduction if we apply them all.
Okay, last one for the moment, maybe there are more coming. To be part of Green Pilot or use the app My Fuel Coach, does it have to be given by the employing airline, or can a pilot individually use the application?
So there are two questions actually. So if I will answer about the My Fuel Coach. My Fuel Coach, yes, it is you have to be part of an airline that is working with us to use this kind of application. So it's not like open to anybody. On the contrary, the Green Pilot, and this is why it is really complementary movement, is everyone can be part of this Green Pilot movement. You can, as a private pilot or individual one, join the movement, promote it, exchange on your initiative, on all the actions you are taking every day in your cockpit to try to fly greener. So yeah, anyone can join the Green Pilot, but only the pilots working with airlines that are working with theirs can use the My Fuel Coach application.
But I would assume that joining Green Pilot would teach a lot of to everybody.
Because in the Green Pilot we exchange with many pilots working with an app such My Fuel Coach, but also you will benefit from their experience and exchange your experience, and you will learn from many initiatives that you can actually do and how much it can allow you and your company to save in terms of fuel reduction.
Okay, perfect. There are no more questions from the audience. I still have some questions, but maybe we can discuss about later.
Yeah, so,
sure. Toralp, can we hand over to your presentation?
Yes, Lisa, gladly. Thank you very much, Erik, for the great presentation and the wonderful PowerPoint presentation you did there. Learned a lot. I actually fell in love with the My Fuel Coach. It's pretty interesting. I'd be glad to use it someday in the future. Hopefully, if the airline does want to use it, I'd be glad to contribute as a Green Pilot and with the use of the application. So thank you very much. Yes, my name is Toralp and welcome everybody. Good evening. I want to talk to you about a system which also helps actively the pilot to reduce emissions such as noise emission or fuel consumption, and therefore can make aircrafts and the flying more sustainable. It is called the Low Noise Augmentation System, shortly abbreviated LNAS, and is actually made or researched and executed by the DLR, the German Aerospace Center. I think, Niklas, you're clicking the presentation, right? Yeah. I think we'll skip the SAI part for now because you briefly talked about it. Just these are our missions, education, awareness, and this is our main page. So you can contact us at any time under the email contact@sai-initiative.org or with my mail, Toralp Eren @sai-initiative.org. Yes, you can follow us on Instagram or listen to our podcast at any time, and we'll be glad to hear from you for further information. So what do I want to talk to you about at the moment or for the next few minutes is about LNAS. First of all, what's the motivation behind LNAS? Why is it used? What is it in general? What's the vision and goal next? And then how does LNAS actually function? And how has been the research conducted before in the last few years? And at the end, I want to go deeper into the benefits of LNAS and have a small outlook on the future of the system, as well as a brief look into DynCat, which is actually an advanced program or system of LNAS. And yeah, we'll just start with the motivation for LNAS. So exactly, thank you. The European Commission has a goal for the aviation sector until the year of 2050, which is, for example, a door-to-door time travel within 4 hours for more than 90% of all travelers within Europe. In addition to this, there is a 45% rise of aircraft movements until the year of 2035, what's expected for that. This results in more carbon dioxide and nitrogen dioxide emissions in the same time. Furthermore, the amount of local residents near major European airports and consequently the people most affected by the emissions are expected to increase by 15%. So there'll be more people living around major airports. This leads to a higher possibility of conflicts between the aviation industry and residents, and also decreases the acceptance for growth of airports and aircraft movements. I mean, that's pretty basic. Nobody wants to live between a very noisy, next to a very noisy airport, which also has flights at night, right? See, for example, Germany and Frankfurt. Yeah. Due to this trend, the topics of environmental protection and noise reduction will play an important role for the aircraft industry in the future, as it does right now. In this regard, the European Commission also declares a reduction of carbon dioxide emission per passenger kilometer of 75% and a reduction of over 90% in nitrogen oxide emissions compared to a typical new aircraft from the year 2000. And this goal is also to be reached until 2050, so we don't have that much time. The aircraft noise also emissions should be reduced by 65%. The noise is not only annoying, but has also a health impact to the affected people, especially during sleep. In summary, the challenge is to decrease the emission of aviation while a constant growth is happening at the same time. Despite the fact that quieter engines and more efficient aircraft configurations are in development to reduce the source of noise as well as fuel consumption, the developments need many years to market maturity and even longer to renew the global fleets. So there are actually aircrafts flying around the world which should be renewed years ago, but it just takes a whole lot of ages to do that. Due to the high cost of physical optimizations on current aircraft and also the long time for integration in a majority of the fleets, this approach is not a short-term solution and cannot speed up the required reductions we want to see until the year 2050. So a midterm alternative to reduce aircraft emissions is to improve the currently applied operational procedures, especially those related to start and approach, including configuration changes for the high lift devices, gear, speed, and altitude, for the following next reasons. Next page, Nicholas. Exactly. The reasons are the variety of configuration changes during approach gives wide possibilities for optimization. I mean, for the most pilots, or for the most thing in the aviation industry, it's pretty strict. So you can't just do anything you want or think of, which might be better. But even though we have very strict procedures during approach and departure, there is in theory a wide possibility for optimization. The next reason is the emission of noise and exhaust directly affect the residents around the airports due to lower flight altitude and short distance between aircraft and ground, and the high accumulation of aircraft near airports where these procedures are used, as a third reason. So you can see here a figure on a steeper approach angle to reduce noise, which has been implemented in 2014, for example, in Frankfurt, where aircrafts are now approaching the airport with 3.2 degrees instead of 3 degrees. So that's just an example. The continuous descent approach in Frankfurt at nighttime, which is used since 2005, and the approaches with an increased glide slope as standard in 2014, are examples which show that procedure changes can be implemented, at least in medium term. However, an effective possibility to improve the situation in short term is an optimization of currently applied procedures without changing itself. In practice, to fly an approach in an optimal way related to noise and fuel consumption means to perform all necessary actions precise in time, which is difficult without further assistance to the pilots. So just to conclude that, approach and landing are typically the most work-intense phases of an airline flight. Pilots have to manage speed, altitude, and aircraft configuration to changing winds, traffic, and commands from the air traffic controller. It is therefore challenging to take noise emissions and fuel efficiency into account. The Low Noise Augmentation System, LNAS, is a pilot assistance system that aims to support airline pilots during these work-intense phases. As said before, it was developed by the German Aerospace Center to help pilots optimize approaches in terms of fuel usage and noise emission by predicting the optimal vertical trajectory and the ideal speed, configuration, and landing gear setting. So the central focus of the LNAS assistance system is on reducing acoustic outliners, which contribute disproportionately to noise pollution. This is especially because individual, particularly loud approaches are disturbing for residents in the area. So next one. Exactly. So I just want to show you the function of the LNAS system. It is, as said before, an assisting system. It is not fully automatic, and it is not even implemented into the aircraft's systems as such, because it is installed as an application on the electronic flight bag. So it can be used on multiple airlines because most of them have electronic flight bags. The responsibility and the execution of the procedure and actions stay with the flight crew at all times. On the right-hand side, you can see the concept of automation degree by Sheridan, which says there can be a system which is manually or fully automatic and even separated in the degrees it has. For example, the LNAS system is a system which perceives information. It takes information and data from the system of the aircraft and from the pilot, which puts input information into the flight management system, for example. The LNAS analyzes these information, so it's also automatic on that page, but the decision-making is just partly automatic. So the LNAS system tells you when to set a flap or put down the gear, but the decision and execution and the making of this decision still lies with the pilot. So let's get to the LNAS function. I'm speeding a little bit so that you guys don't stay here until 10 o'clock in the evening, just heads up. Yeah, in order to assist pilots to realize low noise and more efficient approaches, the German Aerospace Center has developed the assistance system. It is a software solution using flight data provided by a common interface aboard a passenger aircraft. Recommendations are visualized on the electronic flight bag in the cockpit by an intuitive energy-based vertical situation display, or VSD abbreviated. This also indicates the optimal points in time to perform the different actions like setting of speeds, flaps, landing gear, and if necessary, speed brakes. During approach, a continuous correction is carried out to provide the energy optimal profile at any time, even if the predicted approach changes, for example, due to a variation of ground, wind conditions, or the air traffic. So as you can see, the electronic flight bag, which is just partly integrated into the cockpit system, is the tool which is used currently for the LNAS system. And you can see the vertical profile with the obstacles and air traffic information, as well as the altitude information. So what's the LNAS philosophy and function? The optimization of the approach profile and related recommendations are based on an aircraft model simulation and currently supports the Airbus A320 family. For this, know-how was obtained with the DLR's Airbus A320 Advanced Technology Research Aircraft. I think some of them maybe know them by ATRA, the aircraft. The system currently optimizes the commonly used low drag, low power approach procedure. The low drag, low power procedure, as well as the continuous descent, will be explained in the next slide, I think. Yeah, we can go back to the slide before. Thank you. The optimization performed by LNAS is divided into two parts, which I want to tell you now. Before the aircraft enters the approach phase, the pre-planning algorithm that determines a detailed optimization of the current approach with the distinct points in time for all necessary actions within the operating parameters of the related aircraft type, like the speed ranges or of the individual flap settings. Thereby, high lift devices and landing gear are deployed as close to the runway as possible in order to minimize drag during the approach. So maybe if you have some pilots here, they know that the full flaps is mostly just drag, and therefore power has to be set accordingly, which makes much more noise and fuel consumption. So the goal is to minimize all the usage and just do most of the actual acting of the flap settings at the end of the approach. Furthermore, speed brakes are only used if unavoidable to perform a stabilized approach. If they have to be used, they are set as soon and thus as high as possible to minimize related noise impact due to a maximized distance to the ground. Also, both actions lead to a minimized demand of engine thrust. Until the stabilization height in 1,000 feet above ground level, a closed loop real-time correction of all actions is carried out. That's the next phase. Taking into account all varying parameters like changing wind conditions, new speed restrictions from ATC, or delayed pilot actions. This ensures a stabilized flight state at the stabilization height with respect to flight physics and regulations, such as aircraft speed limits or approach procedure boundaries, even under changing conditions, and provides the best possible results at any time. The latest optimization results are shown to the pilots by an intuitive display, as seen before. As mentioned, the optimization algorithm considers the wind condition at any time. Therefore, a linear regression over the following data is carried out. First, the current and previous wind data at the aircraft determined by the aircraft system, and second, the ground wind entered by the pilots via the display on the captain's and first officer's electronic flight bag. Here I just want to put the key point of Erik's presentation in it because it really fits perfectly. So just as Erik said, also in the LNAS system, data is key to a better engage pilots on fuel saving achievements in this point as well, because it's the pilot and the system which work together for a better outcome. So the next page, exactly. During approach, a continuous correction of LNAS given recommendations is carried out to provide the energy optimal profile at any time. The first version, as said, was designed to optimize the low drag, low power approach. And that is actually, the definition of that is to maintain a cleaner aircraft configuration for a longer time. So we want to fly and approach the airport with our aircraft in our clean configuration without any flaps or speed brakes as long as possible, because those are actually first off sources for noise emission and increase of fuel consumption. The second version advanced to optimize continuous descent approaches. This was tested on the airport in Dübendorf in Zurich in cooperation with Swiss International Airlines, Guide, and the Swiss Air Force. So you can see on the left figure, the first optimized low drag, low power, which shows us, and compared to the low drag, low power profile, that the aircraft is configured and sinking later than before. And the most perfect approach for an aircraft would be the continuous descent approach, which shows a very long time of maintaining altitude and then a continuous decreasing until the glide slope or final approach fix, whichever comes first. So at Dübendorf, there were 6 measuring stations to show and measure the approach and noise emissions of the aircraft. There have been, I think, the first one was around 6 to 18 kilometers ahead of the touchdown point. And then also on the German territory in Waldshut, at the furthest measuring points, Hassel and Steinrütt, about 18 kilometers from the touchdown. So in these points, as you can see on the right-hand side, there were average reductions of about 1 to 1.8, so around 2 decibels of noise. So on the red point, there's the ATRA flying, the aircraft from the DLR, without any LNAS system assistance. and the blue points show the assistance on hand. And as you can see, the noise reduction in decibel are definitely lower than the usage approaches without LNAS. Next page, please, Nicholas. No. For the flight tests, which were in Zurich, 23 pilots from Swiss, Edelweiss, and Lufthansa were divided into 2 groups. 14 of them used the LNAS assistance system and were thus shown the optimum time for extending flaps and landing gear. They used this information for a noise and fuel optimized braking phase during the approach. The other 9 tried to fly as quietly and fuel efficiently as possible without the LNAS computer support. In each case, the aircraft was piloted by one of the participating airline pilots with a DLR test pilot acting as co-pilot. Each of the 70 approaches considered began at around 7,000 feet, which is 2,000 meters above sea level, and with 220 knots, which is around 400 kilometers per hour. 43 approaches were flown using LNAS and 27 flown without. The Atra Airbus 2020 was stationed and operated from the Dübendorf airfield, where the scientific research campaigns are repeatedly conducted. The flight data evaluated by the DLR Institute of Flight Systems showed that the pilots with LNAS flew the descents much more consistently and accurately than their colleagues who were flying without the assistance system. The course of the airspeed was also much more steady with LNAS, and the use of noise-intensive air brakes, which is very interesting, was completely eliminated during the approaches with the LNAS system. So you can see here on the left-hand side the elevation differences and speed profiles on the right-hand side. The blue part is actually the consistent use of LNAS, and the red lines are approaches without LNAS. Especially on the speed profiles, you can see the very changing frequency and varying frequency of the aircrafts approaching without LNAS systems. So we have some speed profiles which are exaggerated, some without, with very low speed profiles. But the LNAS system showed us that a continuous and steady use of speed is possible. Okay. So after we know the function and the motivation of the LNAS, I want to conclude with the benefits of the system. The developed assistance system LNAS generates recommendations and on the aircraft and properties, aircraft state and environmental conditions. So it optimizes the approach procedure related to noise emissions and fuel efficiency within all given regulations, so that no additional approvals, for example, for new procedures are necessary. That's a huge thing. So we can work with actual procedures which are used right now and just add the LNAS system and optimize those without the need or the fast need for new procedures at all. The software, which is also a benefit, is compatible with common aircraft hardware and can be integrated in short term. Furthermore, it does not conflict with other common software installed on the electronic flight bag. The display is the interface to the pilots and shows the recommendations in an intuitive way, both as numerical representations and their vertical profile. During approach, the system automatically takes care of most of its own configurations to keep the workload as low as possible and provide the pilots always with the latest solution. The test series under operational conditions show a noise reduction of up to 5 decibels on the ground and a fuel saving of maximum of 25% within the last 3 nautical miles before the stabilization height. In general, the first and second high lift device configuration, so flaps 1, flaps 2, however you may name it, can be done more precisely with the aid of LNAS compared to the approaches without. The huge amount of approaches to an airport by commercial aircraft and the expected growth, we're taking the pandemic aside, of course, of this number in the next decades is a huge challenge for aircraft industry, airport provider, and local governments. LNAS, with its reduction of fuel consumption and noise emission, has a big potential to improve the situation around the airports immediately, or at least reduce the environmental impact of the growing number of aircraft movements. It also enables an easier admission of the Responsible Aviation Authority due to a lower claim on software security and reliability on this platform. Just to conclude this, as said, it's an application on the electronic flight bag, so it's not directly into the cockpit system. It has a contact, but it's not in the flight management system at all. So the fact that ELNAS was, sorry about that, the low software security was the last thing I said, exactly. So ELNAS also was finalist at the Innovation Award of German Aviation in 2018 and in the category reduction of emission. And this confirms the importance of this solution and its goal to achieve in the aviation industry and government even now. By comparing the approaches of the two groups of pilots, the researchers also determined the average fuel savings that can be achieved with ELNAS. So as we heard before with Erik's presentation, there were up to 10 to 50 kilograms of consumption or less consumption in jet fuel. So on the last almost 50 kilometers before the runway, the pilots with ELNAS needed an average 8.9 kilograms less kerosene than without the ELNAS system. So if we extrapolate this to all the Swiss aircraft which used, for example, the ELNAS system with their Airbus 320 flights, I'm taking the flight movement from 2017, so pre-pandemic, ELNAS could therefore save around 500 tons of kerosene per year. Since the assistance ELNAS system can already be used from cruising altitude, so far more before the actual approach, an example from around 200 kilometers ahead of the runway, the savings potential is even greater. Conservatively calculated, this results in annual savings of 3,000 tons of kerosene, which corresponds to around 9,000 metric tons of CO2, if only the Swiss Airbus 320 fleet were to be equipped with ELNAS. As we all know, the Airbus 320 is one of the most common aircrafts in Europe and in the global world. So if the ELNAS system could be implemented in the most flights, there would be a huge saving on jet fuel as well as carbon dioxide. Now, last but not least, for a short outlook, what's happening with ELNAS now and what is DINCAT. So there will be more detailed results or are more detailed results of ELNAS research since 2019 and the DINCAT is expected. I'm gonna come to DINCAT in a short period. ELNAS is now being prepared for serial manufacturing so that more aircrafts, more Airbus 320s can be equipped with that. Lufthansa is, for example, one key airline which is testing it right now with more than 86 A320s who are equipped with the system. The workload will be determined with questionnaires by pilots. So in this point, it's a great thing to see that the research is also taking the pilot's opinion into account by questioning them about the system. And the ELNAS system is being introduced to existing airline groups such as the Lufthansa group. So not only Lufthansa itself, but Swiss, Germanwings, I don't know, the other airlines will also be equipped with the system. And if you look furthermore, the system is so reliable, let's say, or interesting for the airline and the aircraft that it could be possibly implemented into the primary flight display or navigation display directly as a next page, which would take it from the electronic flight bag and take it into the cockpit system directly. So shortly, the DINCAT, since we're running slightly over time, I'll expedite in the presentation. Since July 2020, the DLR coordinates the start of the continuing research project DINCAT, which stands for Dynamic Configuration Adjustment in the TMA, and which Swiss International Airlines and the electronics group Thales Avionics will also participate alongside the existing research partners, such as DLR and Skylab. The aim of the research, which is funded under the European Horizon 2020 and SESAR programs, is to integrate the capabilities of the ELNAS assistance system developed by the DLR into the central navigation computers of commercial aircraft in the future. In this way, noise and fuel consumption optimized landing approaches could be introduced on board many existing airlines. so taken from the electronic flight bag into the aircraft system. The goal of the DynCat project is to achieve more efficient aircraft approaches through changes in air traffic management, as well as supporting pilots with current air traffic control requirements and prevailing weather conditions. By the end of next year, 2022, the researchers want to develop proposals for optimizing operations both on board of the aircraft and on the ground. So there could be a similar system like ALNAS also for ground operations, which is just like the ALNAS, a short-term and very effective term to reduce noise and fuel consumption. So that would be it. If you have any questions, feel free to ask on Menti, and let's see them.
Thank you, Toralp. As I just wrote to the chat, for those of you who have not seen it, in case you cannot stay any longer because we fortunately ran a little bit over time, it's definitely not Toralp's fault. It's just a lot. Please also feel free to just send your questions to contact@saiinitiative.org. It's also in the chat. And if you're interested in SAI as well, please feel free to contact us there as well. And Lisa, I think we're still collecting questions. So for those of you who can stay and want to stay, please feel free to use Menti as well with the same code as before to enter your questions for Toralp. Or just ask them here if you feel like it.
So I don't know if no questions means good presentation or bad listeners or bad presentation. Just need some.
Or maybe it's too warm and too sunny outside.
Not here though.
What about noise reduction during takeoff, Toralp?
Yes, noise reduction during takeoff. Well, there are, that's a question for another system, I'd say, also ALNAS, of course, but ALNAS is actually directly for the approach. Noise reduction during takeoff could be, there are procedures at the moment, for example, the noise abatement departure procedures 1 and 2, which define themselves as how to proceed after the takeoff. Do you want to gain height and altitude really fast so you can overfly close cities or places around the airport? That this would mean a higher thrust or throttle at the beginning to gain the altitude you want. This would take into account, okay, if we have more power at the beginning, there would be more noise close to the airport, but less noise at the further space and areas, or the noise abatement departure procedure 2, which says, okay, we want to start with low speed or low thrust, which takes us higher, slower, but has less noise in the close area of the airport. There are different procedures for the takeoff.
Okay. Do you think that the implementation of ALNAS will be possible everywhere? Or do you think many airports or airspaces are too constrained for it to work?
In my opinion, that's actually an opinion which is not academically coordinate with the DLR or something. So I'm just giving my opinion here. I think it should be possible. It is possible because if you have the data and if you take ALNAS and try to redesign it for different approaches, I mean, why not? Every approach has slightly difference, but at the end, they're actually very similar. One approach has flap settings later, one takes something else into account, but the ALNAS system is just there to optimize approaches. And airspaces, every airspace and every airport has approaches, so they shouldn't be too constrained for it to work.
Okay. So I think that's it for today.
Yeah, think it's quite late already, but I think there was also a lot of information to take in today from the 2 presentations. So thank you to the presenters today, definitely, and thank you to Lisa as well for guiding us through this event. I think both organizations, both the Green Pilots and SAI, would be very happy to stay in touch with you. As I said, if you have any further questions, just let us know. Feel free to join any or both of the organizations at any time. So please let us know if there's anything else afterwards. And thank you for joining today.
Thank you very much from my side as well. Have a good evening.
Thank you. Yeah.
Thank you all. Thank you very much for this joint webinar, and hopefully we can do another one.
Yeah.
Coming day. Yeah. Thank you very much. It was very interesting topics, and glad to see that there are many people working through this great topic about sustainable aviation.
Yeah. Thank you.
Thank you from my side as well, and have a great evening.
And Erik, already one feedback from my side. I would like to have a deep dive